Hello friends! In this lesson, we are going to learn about such an important thing as interpolation. It helps you to control movement between waypoints. Let's start. In all animations that we've created so far, all waypoints look absolutely the same. But in this file, as you can see, the waypoints look completely different. They have different shapes and colors, and this indicates which type of interpolation each waypoint uses. The interpolation defines the character of movement between the waypoints. Let me show you how it works. Let's create a new file and import an image from the interpolation folder. This one. Let's scale it so that it fits our workspace. We can switch the preview quality to final to make it look clearer. Now let's create a red circle and put it in this exact point. Next, let's enable Animate Editing mode and animate the circle to make it move exactly through these waypoints on the image. Let's see what we've got. Notice that the circle doesn't strictly follow these lines. Instead, it moves slightly aside, as if the circle is trying to smooth its motion path. This happens because of the clamped interpolation, which is used in Synfig by default. It's very useful when we need smooth, organic motion. But in general, we might need to show various types of movement in our animations. Therefore, if you use only clamped interpolation, your animations might look monotonous and boring. So let's look at other types of interpolation. To do this, right-click a waypoint. See what we have here? Let's choose the linear type. Take a look how our animation has changed. Now the motion of the circle is sharp and mechanical, not smooth at all. It just moves from one point to another strictly along the lines. That's why this type of interpolation is called linear. Next, let's try the is-in-out interpolation. It looks much like the linear interpolation, doesn't it? Well, if we look closely, we'll notice that our circle pauses a bit at each point. When approaching a point, it slows down, and when moving away, it speeds up, as if each point delays it a little. I mean, when approaching a point, the object slows down, as if passing reluctantly, and after that, it gradually picks up speed again. The next type of interpolation is constant. This type implies not using any transitions at all. All changes occur abruptly. Look. The circle has just disappeared from one point and appears in the other. There is no motion between the waypoints at all. This is very useful when we need an object to vanish suddenly or when we animate a blinking light bulb or something like that. And finally, last but not least, the most interesting type of interpolation, TCB. This type is very similar to the clamped interpolation, but the motion is even smoother. Look, our circle clearly passes through each point, but its motion path is very smooth and organic.